Okay guys, so in this video we're actually going to complete a lesson through Edpuzzle. And for the last two questions here, I'm going to pause the video and ask you to complete it on your own and type in your answer to me. But I'm not going to grade those based on accuracy this time. I know the last time we did Edpuzzle, I graded your responses based on accuracy, but this time I'm not going to do that because I am sending you an assignment that's a homework assignment, and that one is through Delta Math, and that's going to test the accuracy of your solutions here. But this should be a review, so we're going to get started with Unit 2 just by taking a look at linear equations and systems of equations. All right, so you should be able to solve this first equation on your own, and actually I'd like to know if you can. So the video is going to pause right now, and I'm going to ask you to solve this first equation right now by yourself. So we're going to go ahead and solve this, and whenever we're trying to solve for a variable or isolating a variable, it's a good idea to remember that if we've got parentheses, we should try to get rid of those by distributing. So in this case, we've got a 2 being multiplied by the 15x plus 13, and I'm going to distribute that too. So when I do that, I will have 30x plus 26 equals 4x minus 6. And now at this point, you've got 4 choices. There are 4 things you could do to solve this. You could subtract the 30x from both sides if you wanted, or you could subtract the 26 from both sides. You could subtract the 4x from both sides or add 6 to both sides. But I think the thing that makes the most sense here is to subtract 4x. All right. So we now have 26x plus 26 equals negative 6. And we need to do this again. We're going to make another decision here about something that we can move to the other side. I'm going to choose to do that with the 26. And now I'm very close to being done, but I do have to divide both sides by 26 if I want to get that x alone. So I can write my final answer as x equals, and I'm going to reduce that negative 32 26ths to negative 16 13ths. Please don't leave these answers as decimals. We talked about that in the probability unit. We'd like to leave them as exact as possible. So just a note of what we're doing when we're solving these equations that are linear. We're really just using inverse operations to get these variables alone. So if we see addition, we could use subtraction. If we see multiplication, we could use division. We've got all these tools at our disposal. But the major focus of this lesson is going to be on solving systems of equations. So I do want to focus on how to solve something like this. This shouldn't be new. This should be something that you did last year. But we do have 2 methods for doing this. So because we're doing it on Edpuzzle, and I have the luxury of being able to pause the video, I'm going to write down the steps for the elimination method, and then we're going to actually carry it out. Okay, so again, this is something that hopefully you've seen before, but I'm going to use these steps that I just wrote down, and you can paraphrase those or write those steps however you'd like, but this is the general method we're going to use anytime we eliminate. So I've got my 2 equations, and the first thing I need to do is group them so that there are like terms vertically. And I already have that. I've got my x variables stacked above each other, my y variables above each other. I've got the equal signs and the constants all lined up. And that's important. So I could check that box. That's done. Then I need to multiply the equations by constants in order to obtain a common coefficient. And what I mean by that is these x's don't have the same coefficient. In the first equation, the coefficient is 2. In the second equation, the coefficient is 5. And the y variable doesn't have the same coefficient either. I've got a 4 here and a negative 1 here. So I need to pick either x or y and then multiply these equations by a constant so that I get those numbers to be the same. And so I think the easiest thing to do in this case is to choose to multiply the second equation by 4. Because if I do that, then this is going to become a negative 4y, and then I will have a 4 as the coefficient for each of those y variables. I should consider that oftentimes I'll need to multiply the first equation by something as well, so I'll just say times 1 for that one in this case. All right, so now I'm going to write what happens once I actually distribute that 4 to each of these terms, and I have a new system of equations down here that I'm going to solve. So by distributing that 4 I was able to come up with a 20x minus 4y equals 24. And now we're on to step 3. I can add or subtract. I need to decide which of those is going to be better. I'm trying to cancel the y variable. So by adding, would that work? Well, let's see. If I add, and I like to put parentheses there to remind myself that I'm adding each term. So that's 2x plus 20x. 2x plus 20x gives me 22x. And then I have 4y plus negative 4y. And that's going to work out perfectly because I'm going to end up with a 0y, which I don't need to write. And I'm going to erase that in a second. So addition worked here. You get the decision of addition or subtraction because if these were both positive 4's, well then I would have wanted to choose subtraction. And we'll see that in examples further on down the line. So then we have negative 2 plus 24, and that's going to equal 22. So I don't need this 0y here taking up space. Don't forget this is an equation. So next, I'm going to solve for the first variable. So I can solve for x now, and I can do that by dividing both sides by 22. And so now I have that x is equal to 1. So I have my first value for this solution. Now we should keep in mind that anytime we solve a system of equations, we're going to write our answer as an ordered pair, x comma y. So I have my x value, and I'm just waiting to find out what my y value will be. So now I'm going to do my final step, which is to substitute and solve for the second variable. So I have a choice of where I want to put this x. I could put it here, or I could put it there. It's up to me to choose the equation that I think is going to make the most sense. And I'm just going to pick the second equation because I think that's going to be easier to solve. So this is going to say 5 times 1 instead of 5x minus y equals 6, which is 5 minus y equals 6. And I'll just finish solving that. And so we end up with y equals negative 1. And we're going to leave our answer as an ordered pair, just like that. All right, so that's the elimination method. Now we're also going to use the substitution method here. And when we do that, we're going to end up with the same answer. But I'm going to write down the steps for how that method is different, and then we'll follow those steps to solve this one more time. All right, so now we're going to follow these steps, solve the same system, but we're going to use the substitution method. So step 1 says to isolate either variable into either equation. You get to choose. You can pick this equation or this equation, but you've got to get either the x or the y isolated in one of those equations. So I'm going to pick equation 2 because this y looks like it's going to be sort of easy to get alone. So starting from 5x minus y equals 6, what I'm going to do to start is subtract 5x from both sides. Not that that's the only way to do this, but it's the way that I'm going to do that makes the most sense. And then I do need y to be alone, so I'm going to have to divide by negative 1 on both sides. And I'm going to divide by everything by negative 1. So y equals negative 6 plus 5x. Those signs are each going to change. So I've done that. I've isolated the variable y in the second equation. Now, step 2 says to substitute that expression right here into the other equation. So I started with the second equation here. Now I'm going to take this expression that says that y is equal to negative 6 plus 5x, and I'm going to substitute that there instead of y in the first equation. So this is going to say 2x plus 4, but instead of y, it's going to say negative 6 plus 5x equals negative 2. So that's the substitution taking place. That's why we call this the substitution method. So now I'm going to solve this equation just like we solved the one above, and I'll go through that quickly here. So I've distributed the 4 to eliminate the parentheses. Now I'm going to combine like terms on the left side of my equation. So now I'll add 24 to both sides, and now I'm going to divide by 22 on both sides. And I end up with x equals 1, which should not come as a surprise because we know that x is going to equal 1, and we also know that y is going to equal negative 1. So we just solved for the first variable, and now we're going to do the same thing we did with the elimination method and solve for the second variable. So I'm going to take that 1 and plug it in somewhere that I can get the y variable. Now, I've got an expression that's great for doing this already. So I'm actually going to insert that into this equation. And that's going to give me -1. So with the substitution method, that last step is pretty quick. But hopefully you're noticing that these two steps are the same, whether I'm using the elimination method or the substitution method. It's really just the first couple of steps that are different. All right. So we do get the same answer. We end up with 1, -1 in both examples. And I do want to do 2 more here, and these are the ones that I'm going to ask you to do on your own. I'm trying not to make this video go too long, so my solutions to these are going to be pretty quick. What I'd like you to do first is solve this first equation right here, and then I'm going to go through the solution now. Okay, so I get to choose which method I'm going to use. I'm going to choose elimination because they're already stacked really nicely so that the variables are grouped. But I'm going to work on eliminating the y variable, so I'm going to multiply this equation by 2. And my first equation doesn't need to be changed at all. Now I'm on to the next step where I'm going to either add or subtract. In this case, I need to subtract because if I add, these y's are not going to cancel. That would give me a 24y. So I'm going to subtract here, and that's going to give me 4x, 0y, and -8. Now I can solve this equation. And finally, I just need to plug that -2 into either of these equations, and I'll choose the second equation. So I end up with y equals 1. And my solution here then would be -2, 1. So now we'll do the second equation. Again, the same thing. I'm going to ask you to do this one on your own and submit your answer. And now we're going to go through the solution. So this time I would choose the substitution method because x is already isolated. So that's step 1, isolate either variable. That's already done for me. And I'm going to substitute that into the second equation. So I'm going to rewrite this as 5 times 2y minus 2, that's a y, plus 3y equals 16. So I've done the substitution step. Now I need to solve for that first variable, which is going to be y. So now I'll get y alone. And now I'm going to combine like terms on this side. And now I'll finish solving for y. Now that I know y is equal to 2, I can finish here and substitute that into either of these two equations and solve for x. Now I'm going to pick the first equation because that seems like an easy one to use. So I'm going to write that as x equals 2 times 2 minus 2, which is 2. So my solution to this second problem is 2, 2. And please write that as an ordered pair or coordinates. All right, so you're going to have practice on Delta Math related to the solving equations and systems of equations skills, and that's going to be due on Tuesday.